Okay, this is section 9.4, Law of Cosines, and the Law of Cosines is your second tool and your only other tool to solve non-right triangles. So with the Law of Sines and Law of Cosines, given a triangle and enough information, you can solve it. So the objective today will be to use the Law of Cosines to find unknown parts of a triangle. Now, from 9.3 Law of Sines, you know that if you have two angles or side-side angle, you're going to do Law of Sines. All right. But what if you don't have that? What if you have something like side angle side or side side side? Well, in these two scenarios, we're going to use our Law of Cosines. All right. So let's take a look at a triangle where you are given side angle side. That triangle right there. So you see side angle side, 11.2 is adjacent to the included angle, 110 degrees, and 25 is also adjacent to that included angle. So this is side angle side from geometry. And if I'm asked to find this C right here, I'm going to use the Law of Cosines. Side angle side, highlighted. So in triangle ABC, C squared equals A squared plus B squared minus 2AB cosine of C. Now this is our general formula right here, all right? Because not every triangle is labeled with vertices A, B, and C, all right? So you really got to know what the parts mean, okay? This side C right here is opposite the included angle for our side angle side. See the C there and the included angle. And then the A and the B are adjacents to the included angle. All right? And of course, C is the included angle. Because most triangles aren't labeled with vertices A, B, and C, or sometimes you're not looking for side C, you're looking for side B, you really need to know the meaning of each of these versus just the label and fill in the blanks. All right, so here we go. Now this one's set up nice and clean so it can really see the Law of Cosines the way it's written. And this C, if I square it, has to equal the A squared plus, oh, and I should have pointed down here, the A squared plus the B squared, okay, minus 2 times A times B. And look at that. I thought I did general one more time, and I'm putting the numbers in here. So let's look at it like this then. So C squared equals, all right, see this 25? That's A, and I have to square it, 25 squared. See the 11.2? That's opposite angle B, so 11.2 squared minus 2 times my A again, 25, times my B again, which is 11.2, times cosine of the included angle C, which is 110 degrees, right there. Okay? And, you know, frankly, most of the time, you know, when I write this out, I can do this square, and I usually do this multiplication right here. You know, simplify what you're comfortable with simplifying on your first step. Anyway, we don't need C squared, we need C, so let's just take the square root of both sides. So C is approximately, and again, all I'm going to do is take the square root of this right-hand side, and these numbers, I probably wrote them out as is because, you know, 11.2 squared, I don't know what that is right off the top of my head exactly. So I did it just like this, the square root of 25 squared plus 11.2 squared minus 2 times 25 times 11.2, and that's cosine of that 110 degrees. I'm sorry, my calculator ran out of room. And when I punch that out, and you guys make sure you punch this out with me, I have, and this is a side length. Don't forget, side lengths, we are measuring or we are rounding to 3 sig digs. So we're going to write that as a 30.7. And do we have any units? Yes, we do. That's 30.7 meters. So that is the Law of Cosines right there. The most common way I use that is when I see side angle side, just like that. Okay, now I want to make a point here. What do you think the Law of Cosines originated? Well, we can go way back in the history of mathematics. And think about this. What if the measure of angle C is 90 degrees? Well, cosine of 90 degrees, that would be 0. So I'm going to lose this minus 2ab times 0 right there. And what do I have left? C squared equals a squared plus b squared. Because if angle C is a 90-degree angle, don't I have a right triangle? And wouldn't Pythagorean theorem apply? Yeah, there you go. Okay, now another triangle with side angle side right there. Okay, so side angle side, law of cosines. All right, so let's go general again here. And, okay, C squared equals, and I guess the A and the B are interchangeable. All right, so I'm just going to say general right now. I'm going to go A squared plus B squared minus 2 times AB times cosine of that angle C. And there is my general formula for the law of cosines right there. All right, let's put in what we know. So C squared equals, and again, the A and B are interchangeable because the vertices aren't labeled on this triangle. So I probably call the A 3, so A squared would be a 9. The B would be a 7, so B squared would be 49, minus 2 times A times B, 3 times 7, that's a 21, and then cosine of my included angle, 130 degrees. All right, just like last time, we're going to take the square root of both sides. So C is, now one like this, I'm probably going to simplify, all right? But I'm going to go the square root of, and then notice what I did. Hey, I can handle this. 9 plus 49, there's a 58. Minus 2 times 21, 42, cosine of 130, all right? The less I need to put into my calculator, the more likely I'm going to be successful, okay? When I have to put in all kinds of terms, these older calculators, my buttons stick sometimes, and it's just, so I try to put in as little as possible. But again, do what you're comfortable with, and you would be fine doing the square root of that entire thing and writing it out exactly the way you see it. Anyway, this C is what? So that's a distance, so I need 3 sig digs, 9.22. And then I think, do I have units? Yes, I do. My lengths are in centimeters. So there you go. You just found C. Okay, now, at Iwako High School, when I took this pre-calculus class and I learned the law of cosines, this is the only formula we learned. And if we had to solve for the angle C, all right, we'd put everything in just like this and then solve that literal equation for the C. All right, so now that took a little more time. So, in the textbooks today, they give you 2 forms of the law of cosines so that you can be a little more efficient. So whenever I am looking for an angle, I take this and I use the form of the law of cosines where it's cosine of C equals. So we're going to solve for this cosine of C right now to save you a lot of steps down the road. All right, well, the first thing I would do if I'm going to solve for this cosine of C, how about if I add 2ab cosine of C to both sides? So that would give me a 2ab cosine of C plus C squared on the left, and then nothing but my a squared plus b squared on the right. All right, now what? Well, how about we subtract the c squared, leaving me 2ab cosine of C equals a squared plus b squared minus that c squared. And then, of course, you're just going to divide by 2ab to get cosine of C equals the a squared plus b squared minus c squared divided by that 2ab. And that is the law of cosines that we use when we're either solving for the trig function cosine of C or the angle C. So here it is right here, the law of cosines. In triangle ABC, cosine of C will always equal a squared plus b squared minus c squared over 2ab. Now remember, every triangle is not labeled with vertices A, B, and C, or we're not always trying to find angle C. Sometimes we need angle A or angle B. So know what these mean. The C is the included angle. An A is an adjacent side. A B is an adjacent side. A C, that's the side opposite my included angle. All right, so let's put this in action. Okay, so side, side, side. Well, let's take a look at a triangle where they gave us all three sides. Nice. So now it says solve the triangle, and remember, solving a triangle means you need all 6 parts of the triangle. You need the 3 side lengths, which we already have here, but then you also need those 3 angles. So we're solving for an angle, so let's write down our general formula for the law of cosines when we're solving for an angle. And that's what? Cosine of C equals, and then over here, what do we got? We've got the fraction with the a squared plus b squared minus c squared over 2ab. There it is right there. Now, again, this is what I was talking about earlier. This triangle is not labeled with vertices A, B, and C. All right, so we've got to know what C, the angle C means, what side A, side B, and side C mean to actually apply this. So to determine which angle we're going to go cosine of, we just pick an angle. I'm going to do this theta right here. All right, so I'm going to use this formula, but my cosine of C now becomes cosine of theta. And that has to equal, now A and B are the sides adjacent to the theta, so that would be what? The 5 and 12. So if I go 5 squared, 25, B, 12 squared, 144, minus C, the side opposite the angle I'm trying to solve for, squared. All right, so that's minus 100 over 2 times A times B. And again, A times B, 5 times 12, that's a 60. All right, now I want to make a little point right here. I always look at this expression on the right to think about what kind of angle am I going to get. Now, 25 plus 144 minus 100, isn't that 69 over 120? So that's going to be a positive number. And you know that cosine is positive in quadrant 1 and quadrant 4. So if I have cosine of theta equals a positive number, if this expression is greater than 0, that implies my calculator is going to give me a quadrant 1 angle. And you know what? I want a quadrant 1 angle, because doesn't that angle theta right there look like an acute angle? So cosine is positive in quadrant 1. You know we're going to get that acute angle right there. So theta then is approximately, all right, and this is going to be acute, I guarantee it. But what am I going to do? I'm going to get out my calculator, and I'm going to solve for theta by doing inverse cosine of both sides. And you have to be really careful here. And again, you might simplify a little bit. So I know it's going to be acute, but let's see what the calculator gives us. So I did this, inverse cosine of 69 over 120. And what did I do? Well, I went 169 minus 100, that's my 69. 2 times 60, that's 120. So I'm doing inverse cosine of 69 over 120. And again, if you want to just punch it out the way you see it, you can do so. Just be careful with your parentheses. Part of the reason I simplified is so you can see everything really clearly here. Now, when I put that in my calculator, I got that 54.9 dot dot dot, and then I think to myself, that's an angle. Angles need to be rounded to the nearest tenth of a degree. So this angle theta is approximately 54.9 degrees. Okay, so let's find either of the other two angles, and it doesn't matter which one. Just to change things up and make a point, I think I'd like to find this obtuse angle right here. So I'm going to solve for alpha in the law of cosines. So instead of cosine of C, I'm going to write cosine of alpha equals adjacent squared, how about a 5 squared or 25, plus the other adjacent squared, that's a 10 squared or 100, minus the opposite side squared, well, that's a 144, over 2 times the product of the adjacents. 5 times 10, that's 2 times 50. Now if you look at this one, I've got 125 minus 144. That's a negative over a positive. So if cosine of alpha is a negative number, that is less than 0, right? Well, isn't cosine negative in quadrant 2? So my calculator is going to give me the quadrant 2 angle because cosine is negative in quadrant 2. All right? And isn't a quadrant 2 angle obtuse? And isn't that what we're expecting right there? Beautiful. So again, this one, let's take inverse cosine of both sides, and be careful when you put this in. Practice this stuff on your calculator. Yep, we already talked about that being obtuse. So I did inverse cosine of, well, I added the 100 and the 25, 125 minus 144, and I just put that numerator in parentheses and I divided by 100. All right, and what did I get? 100.9 dot dot dot. Now remember, this is an angle, needs to be rounded to the nearest tenth, and so wouldn't that be 101.0 degrees? Now again, if you're rounding to the nearest tenth and you get a 0.0, if you write that 101 degrees, that is absolutely fine with me. All right. So we have 2 of our 3 angles. Now we could get beta with the law of cosines again, but I'm going to go back to geometry and use the triangle sum theorem, because beta, wouldn't that have to equal by the triangle sum theorem? Don't forget, what do these 3 angles have to add up to? 180. So that means this beta would be 180 minus the sum of these 2 angles right there. So 180 minus the sum of 101 and 54.9, that'd be 155.9 degrees right there. And that equals, and I put approximately there because this was rounded right there. You know, if you put an equals there, that'd be fine though. And when I punched that out, I got 24.1 degrees. So there's my 3 angles of this beautiful triangle that we were originally given side, side, side for. And, you know, if you have them written off to the side, labeled like that, that's great. Personally, I always like to put the stuff into my diagram. So theta up here was 54.9 degrees. Alpha was 101 degrees. And beta was over here, the acute angle, and that's 24.1 degrees. And there you go. That triangle has been solved. Okay. Oh, look at this one now here. We see not 1, 2, 3. I think I see 3 triangles there. All right. And what are they asking for? What does this mean, AD equals? Well, again, go back to geometry. If you write vertices A and D just like that in geometry, that means the distance of the segment from A to D. Right there, that segment right there. Okay, so let's see. I don't have enough information directly to just focus on this triangle on the left right there. So what I'm going to have to use is the side of the larger triangle to find that angle B right there. All right? Right there. If I can find that angle B, I can answer this question right there. Okay? So, and by the way too, and you're going to see in a minute, I really don't even need angle B. What I'm going to need is cosine of that angle B. And I'll show you why in just a second. Okay, so let's write out the law of cosines given side, side, side. And we use this when we are looking for an angle. So in general, that's cosine of C equals, all right, and then what do you have? The A squared plus the B squared minus the C squared over 2AB. And remember, all right, this triangle is labeled ABC, but then when we focus on finding this length right here, we're no longer going to have those. So you've got to remember what these all mean. C is the included angle. A and B are the adjacent sides to the included angle. And C is the opposite side of the included angle. And that included angle is the angle that we're solving for. So we're going to do this like this. And again, we're just going to find cosine of B because I'm not going to need the angle B to answer my final question. I'm going to need cosine of that angle. And you'll see why in a second. So cosine of B, and now remember, we're going A, an adjacent to angle B. Well, that 5's adjacent to angle B, so I'm going to square that, 25. And this 6 is adjacent to angle B. Square that, and I've got a 36. And the 7 is opposite angle B, and square that, minus, and I've got a 49. Over 2 times A times B, 5 times 6, that's 2 times 30, right there. All right, so angle B, okay. Well, again, all I need is cosine of B, so let's punch this out on our calculator. And I punched that out, and I got exactly 0.2. Now, a lot of people go, okay, so inverse cosine of 0.2 to find angle B, but I don't need the angle of angle B because what am I looking for? This segment AD, what's the length right there? That's what I need, all right? And to answer that, I want cosine of the B, which is 0.2, and you're going to see why right now. So that B, okay, we're doing the law of cosines given side angle side, and I know I don't have the angle yet, but I have cosine of that angle, and I'm looking for a side here, so I'm going to go in general. That's going to be what now? Let's think. This is cosine of C, so this is the side C squared equals the A squared plus the B squared minus the 2AB cosine of that C right there. Okay, so now we're going to write this, but we're solving for the B, so I'm going to go B squared equals, and this is why I need to know what everything means. All right, what's adjacent to angle B? The 5 and the 2. So I'm going to go 5 squared, 25, plus the 2 squared, 4, minus 2 times those adjacents, 5 times 2, 10. All right, and then I need my cosine of B right here, and instead of going cosine of angle B, I already know cosine of B is 0.2. That's why all we needed to do up above was find cosine of B. Now, take the square root of both sides. And, first, I punched this out first, and I got exactly 25. That kind of surprises me. I guess let's take a look, though. 29 minus 20. Okay, hold it. 29 minus 20 times 0.2. I'm going to punch that out and double check that. All right, so let's go. 25 plus 4 minus 2 times 10 is 20 times 0.2 and 25. Sure enough. Okay, well, I like that. B squared is 25, so that means that distance from A to D, or that B right there, would be the square root of 25, and that's 5. And you know what? 5 what? Well, I don't have any units in the diagram, so I have to go 5 units right there. And by the way, this 25 kind of surprised me right here, but let's look at this diagram. Do you agree that that looks like an isosceles triangle right there? I've got a 5 here, I've got a 5 there, and it means these two base angles would be the same too, right there. Oh, this is so cool. So now you have all the tools you need to solve non-right triangles, all right? So you put together your right triangle trigonometry with your law of sines and the law of cosines, and the applications are endless. All right, so I think I'm going to end this with this little note that I'm going to pass out to everybody, and it just kind of help you out. I think it becomes pretty automatic, but now you have it on paper. So given side angle side, I'm going to use the law of cosines to find the third side and then one of the remaining angles. Side, side, side. So this is essentially what we've been talking about. If I'm doing side angle side or side, 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 I'm using the law of cosines. If I have two angles, I'm using the law of sines. All right. And if I have side angle, remember that's the situation where, yes, I'm going to do the law of sines, but I have to be aware that side angle may give me no triangle at all. It might give me one right triangle, or it might give me two triangles, one of them with an obtuse angle. All right. So you guys have fun. Let me know if you have any questions. And I would like you to do page 352, 1, 2, 5 through 9 odd, 17, and 18. You guys have a great day.